Good morning, my dear students. Today's topic is the mean value theorem. So there are two mean value theorems. One is Rolle's theorem and another is what? Lagrange's mean value theorem. So first of all, I will discuss about the Rolle's theorem. What is Rolle's theorem and what is its geometrical interpretations? So the statement of Rolle's theorem is, if a function defined on a closed interval AB be continuous in the closed interval AB. Throughout the closed interval AB, the function is continuous and differentiable in the open interval AB, except the endpoint A and B. The function is differentiable throughout its, that is, domain, such that functional value at the point A and point B is same, fa is equal to fb. Then the theorem says there exists some means maybe more than one or maybe one. There exists some c between A and B, between the that is in the open interval A and B, such that f dash c equal to 0. That means the derivative of the function at the point c equal to 0. That means what? Dy by dx at the point equal to what? 0. F dash c means what? Slope of the tangent. It means slope of the tangent at the point c. And slope of the tangent at the point c equal to 0 means at the point c in the domain of the function, the slope, the tangent is parallel to what? X-axis. Okay. Slope of the tangent is 0 means what? Tangent is parallel to x-axis. Or suppose that this is your supposed domain closed interval AB. A function is defined in this closed interval, and given that at the point A the functional value is what? Fa, and at the point B the functional value is fb. Okay, so if fa is equal to fb and throughout its domain the function is continuous, and between A and B, between A and B what happen? F dash x exists. Between A and B f dash x exists. That means the function is differentiable. Function is differentiable means what? On every point between every point in the domain there is a tangent. You are getting what? Existence of tangent. F dash x means what? The slope of the tangent. That means in every point in the domain you are getting what? A unique tangent. And if this is satisfied, the function is continuous and the function is differentiable in the open interval AB and continuous in the closed interval AB, such that this functional value is equal to that functional value, then the theorem says there exists at least one point, minimum one point between A and B are there. Suppose this is a C, a point lying between A and B, where f dash c equal to 0 means what? There is a tangent at the point C which is parallel to what? Which is parallel to what? X-axis. Means f dash c equal to what? 0. F dash c equal to what? 0. So at the point C, slope of the tangent is denoted by this term, and since the tangent is parallel to x-axis, x-axis has a slope 0, so tangent has a slope f dash c. Then since both are parallel, so their slope are what? Same. This is the statement of a the Rolle's theorem. That means what happens? If this is the point C, then corresponding y coordinate is what? Fc, and this particular point is denoted by c comma fc. This is the point. In this point lies on the curve. On that point what happens? Tangent is what? Parallel to x-axis. And if you consider the domain only, then x coordinate will be the point inside the domain. This is called point in the domain. This is the domain, okay. So on that domain, that f dash c equal to what? 0. The statement tells if the function f is continuous in a closed interval ab and differentiable in ab such that both the functional value are same at the end point, then there exists at least one point between what? A and b where tangent is parallel to x-axis, means f dash c equal to what? 0. F dash c is nothing but slope of the tangent at the point c. At the point c. So this is the actually the theorem tells, and this is its geometrical interpretations. Geometrical interpretation is at the point c, fc on the curve, the slope of the tangent is 0. That means tangent is parallel to x-axis. Tangent is parallel to x-axis. Okay. Another diagram, figure I am drawing, and you see you will get interested. Very interesting. Suppose that this is the domain of the function. Okay. Here you see the functional value at the point this fa and fb. Both are same. Functional value are what? At the point a and b are both are what? Same. So you can say 0. That fa is equal to what? There is no y coordinate. Fa and fb are same. So there is a tangent you see. There is another tangent you can see parallel to what? X-axis. Parallel to x-axis. This is the point suppose C1 and this is the point suppose C2. Both are lying between what? C1, C2 belongs to what? Open interval AB. Okay. And at that point C1, f dash C1 equal to 0 and f dash C2 is equal to 0 from the figure, because at the point C1 tangent is what? Tangent is what? This one, and tangent is parallel to x-axis, means what? At this point C1, f dash C1 representing the slope of the tangent at the point C1, and this is the tangent. And since tangent is parallel to what? X-axis, therefore what happen, you can say that is tangent is, since tangent is parallel to what? X-axis, therefore f dash C1 representing the slope of the tangent, and since it is parallel to x-axis, therefore it is equal to 0. Similarly at the point C2, this is called the tangent and its slope is f dash C2, and since it is parallel to x-axis, so it is equal to what? 0. It is equal to what? 0. Okay. So there may be one point or more than one point. If the function is continuous in a closed interval AB and differentiable in open interval AB, then there will be some point. Some means maybe one or more than one. In this case there are one point. In this case there are 2 points where tangent are parallel to x-axis. Means the derivative of the function, that means f dash x equal to 0 at that point. Means f dash x is equal to at C1, means f dash C1 equal to 0. F dash x equal to 0 at the point what? C2, therefore f dash C2 equal to what? 0. This is the geometrical interpretation of what? That is Rolle's theorems. The Rolle's theorems tell if it is continuous in a closed interval AB, what is A and B? A and B are any two real numbers. Any two real numbers. So if a function is continuous in a closed interval AB and differentiable in open, differentiable means and in every point there is a unique tangent. You will get tangent, okay? Unique tangent. There is only one tangent. That's why the function is differentiable. And at the end point, what happens? It cannot be differentiable because at the end point there are many tangents. So tangent is not unique. That means f dash x is not unique. So at the end point, the function is not differentiable. That's why it is written as open interval. Okay? I hope you understand. So this is called the Rolle's theorem. So again I read the statement. If a function is differentiable in a closed interval AB, which is defined in the closed function is defined in the closed interval AB and continuous in a closed interval AB, differentiable in open interval AB, there are two conditions, and third condition is that the end point a and b, the functional value, this functional value and that functional value are same. Over here it is functional value are what? 0. Here fa equal to what? Fa equal to what? 0. And here fb equal to what? 0. And therefore both are what? Same. In such cases, the Rolle's theorem tells that there exists some point in between open interval ab such that f dash c equal to what? 0. That is called the Rolle's theorem. So let us solve a few questions related to this particular theorem. Then we will understand better what actually Rolle's theorem is. So this way you have to remember the Rolle's theorem, statement of Rolle's theorem. So repeatedly if you utter it, then you understand, and you also remember this. The function is defined in a closed interval ab, and if the function is continuous in a closed interval ab and differentiable in open interval ab, then there exists some point c in open interval ab such that f dash c equal to 0. F dash c means slope of the tangent to the curve at the point c, and which is equal to 0 means the tangent is parallel to x-axis. Tangent is parallel to x-axis. Okay. Let us take a question. Verify the Rolle's theorem for the function fx equal to x square minus 2x, x square minus 2x in the interval, suppose (0 to 1), in the interval 0 to 1, where x belongs to what? Domain of the function is closed interval 0 to 1. So how to verify? The condition of Rolle's theorem should be satisfied. First condition is what? The function should be what? And continuous in this closed interval, and function should be differentiable in this interval, and the value of the function at the extreme point should be same. Okay, the given function is see, it is a polynomial function, which is a polynomial function and hence it is continuous in the closed interval, because we know that polynomial functions are always continuous. So since the domain of this polynomial function is this one, since it is a polynomial function which is always continuous, hence it is continuous in the closed interval, in the closed interval 0, 1. And also fx is differentiable in open interval 0, 1, because if you derivative, you will get twice x minus 2. Twice x minus 2 is again a polynomial function, and polynomial functions are also differentiable. Therefore, now f dash x equal to what? Twice x minus 2. Also, you see the functional value at the extreme point, f0 equal to what? f0 equal to what? 0, and f1, if you put the value of 1 here, f1 equal to what? I'm sorry, something here. You write x square minus x, I'm sorry, x square minus 1. During your question, this is x square minus x. Okay, then f1 is equal to what? 1 minus 1 is equal to what? 0. Okay, therefore f0 equal to what? f1. So from the first statement, the function is continuous in the closed interval AB. In the second statement, fx is differentiable in open interval f0, 1, and the functional value are same. So all the condition of Rolle's theorem are satisfied. All the condition of Rolle's theorem are satisfied. They write all the condition of Rolle's theorem are satisfied. All the conditions of Rolle's theorem are satisfied, and since the condition of Rolle's theorem are satisfied, so by Rolle's theorem, so there exists some C belongs to the open interval 0, 1 such that f dash c equal to 0. This is the Rolle's theorem tells us. Okay, so when the condition of Rolle's theorem is satisfied, then there exists some c in the open interval such that f dash c equal to 0. Now your f dash x is equal to twice x minus 1. What is f dash c? F dash c will be twice c minus 1. So you can write twice c minus 1 is equal to 0, implies c equal to half. Now you have to check this c belongs to this open interval or not. Since half is a number which lying between what? 0 and 1. Therefore, it means Rolle's theorem has been verified. Has been what? Verified. If whatever c will, कोई अगर c अगर मिल जाता और अगर ये ओपन इंटरवल नहीं आता, सपोज आपको मिल गया था, सपोज ऐसा अगर मिल जाता, सपोज c इक्वल टू 2 हो जाता, तो it does not belongs to this, and you can tell and you can conclude that that is Rolle's theorem is not verified. Since the value is what? Half, and which is belongs to this interval, therefore Rolle's theorem is verified. So you can say the hence Rolle's theorem is verified. Rolle's theorem is verified. Okay, so in this way you start the problem and end up the problem. Okay, so first you have to satisfy all the condition of Rolle's theorems, and after satisfying you write this statement that there exists some c belongs to this f dash c equal to 0. We suppose there exists some c, we do not know what is c, then we have to check whether this c, we after calculation whatever we get, this c must belongs to this. If it is belongs to this, then we can say it is verified, Rolle's theorem is verified. And if it does not belongs to the open interval, whatever the open interval for that particular problem, in this open interval, if it does not belongs, then we can conclude that Rolle's theorem is not verified. Okay, so this is actually Rolle's theorem, and from here you can say that there are some point. If you add in this point and some addition in this point, also you see f of c means f of half on this particular function. Your function is what? Fx is equal to x square minus x. So what will happen? 1 by 4 minus half. 1 by 4 minus half is equal to minus 1 by 4. Okay, that means that is at the point x coordinate was half. What is y coordinate? 1 minus 1 by 4. Half comma minus 1 by 4. There is a point that is at the point this on the curve. At the point this on the curve, the tangent is parallel to x-axis. That means what happened? F dash half is equal to 0 in the point, that is half is a point in the domain. In the domain, at the point half in the domain, the tangent is parallel to x-axis. And when x is equal to half, means what? In the domain का एलिमेंट को क्या कहते हैं? x से रिप्रेजेंट करते हैं. So when x is equal to half, what is y coordinate? It is represented by f half, means fc, which is equal to minus 1. This is y coordinate, and ultimately we get a point half minus 1 by 4 on the curve. ऐसा it is a quadratic equation, so curve shape ऐसा होगा. So जैसे भी हो तो एक ऐसा मिल जाए, जो भी हो तो हमें भी ये कोई भी एक पॉइंट होगा जहाँ में सपोज ये पॉइंट है हाफ minus 1 by 4. On this point, tangent is parallel to x-axis. This is your domain. Suppose 0 to 1. This is the domain. Within the point there is a half. उस half के corresponding y coordinate क्या होगा? minus 1 by 4. Suppose that. That is diagram will be little different one. So in this point, the tangent is what? Parallel to x-axis. And this is what actually the geometrical interpretation of this particular Rolle's theorem of that particular problem. Okay, thank you very much. Thank you. In the next class, I will solve few problems related to this particular theorem and also discuss about Lagrange's mean value theorem and its geometrical interpretation. Thank you. Thank you very much.